We're going to take a quick look at geometric sequences. First of all, a geometric sequence is a sequence where the ratio of consecutive terms is constant. That ratio is usually called the common ratio, and most of the time we're going to use R to indicate that. So if I look at this geometric sequence right here, and I think about what do I have to do as far as a ratio goes to get to the 6 from a 3, well, I would have to multiply that by 2 over 1. To get from the 6 to a 12, I would have to multiply it by 2 over 1. 12 to the 24, I'd have to multiply it by 2 over 1. So in this case, my common ratio is 2. Now if we look at what we did, we technically have an a sub 1, a sub 2, a sub 3, and a sub 4 here. Well, now I took my a sub 1 value, I took my 3 times 2 in order to get 6. So I took my a sub 1 times my ratio in order to get a sub 2. Now if I solve that out for r, I have to divide both sides by a sub 1, and I get r is equal to a sub 2 divided by a sub 1. You could do that for the 6 and the 12. I had a sub 2 times my ratio is equal to a sub 3. Well, when I divide both sides by a sub 2, I get a sub 3 over a sub 2 is equal to my ratio. And this pattern would continue on and on and on. That's why most of the time we're going to see our ratio as a sub n plus 1 over a sub n. Now this notation here, this a sub n plus 1, is just saying one term farther than my nth term. So if my nth term was the 6th term, then my n plus 1th term would be the 7th term. So I take my later term divided by my earlier term. Okay, here's our first example, writing a rule for a geometric sequence. If we look at this, the first thing we do need to figure out is that we do have a geometric sequence, and we would do that by finding our ratios. So we would take 12 divided by 4, which gives us 3. We would take 36 divided by 12, gives us that same 3. And then we would have to take 108 divided by 36 and make sure we got a 3 again. So this one does work out. And if we look at what we have here, we know that our a sub 1 is equal to 4, and we know that our common ratio is equal to 3. We're going to use this information to come up with the formula for writing a geometric sequence. So let's think about, in order to get my a sub 2 term, I had to take my a sub 1 and I had to times it by r just one time. Now to get my a sub 3 term, I had to take a sub 2 times r, but really a sub 2 is equal to a sub 1 times r. So I'm going to use substitution here, and I'm going to replace a sub 2 with what it's equal to. So I really had a sub 1 times r, which would be a sub 1 times r squared. Now to get a sub 4, I had to take a sub 3 times my r. Well, a sub 3 is really equal to this, so I'm going to replace my a sub 3 with that, and I'm going to have a sub 1 times r squared times that r again, which is a sub 1 times r to the third. So now if you see our pattern, our next one, our a sub 5, would be a sub 1 times r to the 4th. And our a sub 6 would be a sub 1 times r to the 5th, because the pattern would continue. So now what I want to think about is how could I write that in terms of a sub n? Well, I know I have to have my a sub 1 because that's been constant in each one of my terms here in my pattern. And I know I'm going to have to multiply it by r to some power. But now it's the power that we have to figure out, and we want to write it in terms of n. Well, in this first one, my n was equal to 2. In the second one, my n was equal to 3, and then I used n is 4, 5, and 6. So look at how our exponent relates to our n. It's always 1 less than our n. So, in order to indicate I need 1 less than n, I'm going to do n minus 1. This is actually our rule for writing a geometric sequence. We have a sub n is equal to our initial term times r raised to the n minus 1. So we're going to end up using this pattern here in order to solve some of these problems. Now it's very important that you understand this n minus 1, the whole thing is the exponent. Alright, so we're going to write a rule for the nth term of the geometric sequence, and then we're going to find the 12th term. So what I need to do first is I need to find out what my r value is. So I need to think of my common ratio, which means I can take my a sub 2 divided by my a sub 1 term. When I do that, I end up getting 1.5, so that's equal to my r. Now if you want to check it with the next two terms just to make sure you didn't miscalculate it, you can take your negative 18 divided by a negative 12 and you'll come up with that same 1.5. So we have our r value now. Then I still need to figure out what a sub 1 is. Well, since they gave me the sequence here, I already have my a sub 1. Now I can use all that to write my rule. So I'm going to have a sub n is equal to my a sub 1 term, which is negative 8, times r, which is 1.5, raised to the n minus 1. Now the reason we don't have a number for n is because we are writing a rule for the nth term. We don't know what the nth term is yet. So this is the first part of it. There's my rule. Then it says find the 12th term. Now they've given us an n. So I would write this out as a sub n, because I'm trying to figure out that value, is equal to negative 8 times 1.5 raised to the 12 minus 1. Well, 12 minus 1 is 11, so you would actually just take your negative 8 times 1.5 raised to the 11th. You get negative 691.980, and then the decimal keeps going on for a little bit. So that would be our 12th term for this particular one. Okay, now this one says write a rule for the geometric sequence if a sub 3 is 12 and r is equal to negative 2. So we're still going to be using that formula that a sub n is equal to a sub 1 times r to the n minus 1. Now this one's a little bit different because I don't know my a sub 1 value like I did before. But what I do know right here is that when n is equal to 3, a sub n is equal to 12. So I'm going to temporarily plug these values into my formula in order to figure out a sub 1, because I have to have numbers for my a sub 1 and my r value when I'm all said and done. So I'm going to go ahead and put in 12 is equal to a sub 1, because that's unknown right now, times negative 2 raised to the 3 minus 1. So now when I do this out, I've got an algebra problem that I can solve. Take the 3 minus 1 and get 2. So negative 2 raised to the 2 is positive 4. Make sure you put that negative 2 in parentheses. So I have a sub 1 times 4 is equal to 12. Divide the 4 over, and I get a sub 1 is equal to 3. Now I can plug that back into my formula and let a sub n go back to a sub n. Put my 3 in there. Put my r in there, and then let my n minus 1 go back to n minus 1. So now I have my rule for that particular sequence. Alright, our last example here, we're actually going to have to do a little bit more calculating than we have before. And it's because they don't give us the common ratio this time. So what I need to do is I'm given two terms here, and for this first one I know that n is 5, and the second one n is equal to 9. Well, if I just use my first set here, my 22 and my 5, and I set that equation up, I would have 22 is equal to a sub 1 times r raised to the 4th, because 5 minus 1 is 4. Now the problem I run into is I have two variables here, and I need numbers for both of these variables in order to actually get my rule. Well, with one equation and two variables, I can't actually get numbers for them. So then I have to use my second term and set up a second equation. That way I can make a system of two equations for two variables. So my second one, I have 1782 equals a sub 1 times r, and this time it'll be raised to the 8th power because 9 minus 1 is 8. Now I have two equations with the same two variables in them. I'm going to use substitution in order to solve this. So I'm going to solve my first equation here for a sub 1. So divide both sides by r to the 4th. That cancels out to be a 1. So I have 22 over r to the 4th is equal to a sub 1. I'm going to plug this value into my other equation. I'm substituting it in there. That way I'll be able to solve for my r. So I'm going to replace that a sub 1 with 22 over r to the 4th. And now I'm going to simplify. So my rules for exponents here tells me that when I have the same base and division, I subtract my exponents, so I'm really left with r to the 4th on top and just the 1 on the bottom. So I have 1782 is equal to 22r to the 4th. Now when I divide both sides by the 22 in order to get rid of it, I'm left with 81 is equal to r to the 4th. Now to get rid of that 4th power, I have to take the 4th root of it. So I'm going to 4th root both sides, and when I do that, I end up getting r is equal to 3. Now since I took an even root, I technically have plus or minus here. So my ratio could actually be a positive 3, or it could be a negative 3 in this particular case, and we don't know which. Now this is only a piece of my rule. I still need to figure out what my number is for a sub 1. Well, I can come back to one of my original equations here, just like you do with regular systems of equations, and I'm going to plug in what I got for r. So I have 22 is equal to a sub 1. I'm going to use the positive 3 for my r and raise that to the 4th power. So you would do that part first. You would do 3 to the 4th power, which gives you 81. So we have 81 times a sub 1 is equal to 22. Divide both sides by 81, and we would get 22 over 81. Now you probably don't want to write that as a decimal, because if you actually divide that out and write it as a decimal, you're not going to have an exact answer. So just leave it as 22 over 81. Now I've found both pieces as far as numbers that I need to write my rule. So I can write my rule now as a sub n equals, I'm going to use my 22 over 81 times my r, I'm going to use the positive 3 here, raised to the n minus 1. Or my rule could have been a sub n is equal to that 22 over 81 times negative 3 raised to the n minus 1. Now, we don't know which one it is strictly based off of the information here, so it could actually be either one of them. The last part here says find the 30th term. Well, I'm going to plug it into both equations. So I'm going to let my n be equal to 30, and I'm going to substitute it into both of them. So it would, I would be using an exponent of 29. Now the reason I'm going to do it into both of them is because it could possibly change my answer. So you would take your 22 over 81 and you would multiply that by 3 raised to the 29th power, and you get, let's see, I'm going to write that over here. You get 1.86, and it keeps going, times 10 to the 13th power. So you get really a large number. Now watch what happens if I do the same thing, but I use negative 3. So instead of timesing it by 3 to the 29th, I times it by negative 3 raised to the 29th power. When you do that, you get the same number, but you get a negative. Because what a negative ratio does in a geometric sequence is it makes them alternate signs. Now I know this isn't an exact answer because I did round it, but that was for space purposes. So for this, we don't actually know which one it is. Whoops. So when they want me to evaluate it, I'm going to evaluate it for both of them, but the only difference should be that one is positive and one is negative.